Hello and welcome to helpyourmath.com. In this video, we are going to look at question 2 of the Math 206.5 final exam review. The question states, if cosine of theta is equal to the negative square root of 2 over 3, sketch theta in the coordinate plane, and find tangent of theta and cosecant of theta where theta terminates in the second quadrant. So we have a little bit of information about our mysterious angle theta. We know it terminates in the second quadrant, so if we were to draw our coordinate plane, we know it's going to be somewhere up here, right? This is the second quadrant. What information does cosine of theta tell us about this angle? Well, we know it's negative, which it should be. Cosine is negative in quadrant 2 because cosine is the ratio of the x value to the radius. And x is negative, so that means that the x-coordinate of one x-coordinate on our theta is the negative square root of 2. If we're going to find tangent theta and cosecant of theta, then we need one more piece of information. It would be good to know the y-coordinate because tangent is y over x, it's the ratio of y over x, and cosecant is the ratio of r over y. It's the reciprocal of sine, and it would be y over r. To figure out our mystery y value, we would do the Pythagorean Theorem. In the coordinate plane, we know that x squared plus y squared is equal to r squared. X squared, in this case, x is negative square root of 2, so negative square root of 2 squared, plus y squared is equal to 3 squared. And we know over here that the negative belongs with x because r is always positive. The negative square root of 2 squared becomes just positive 2. It's positive because we squared a negative, and when you square a negative, that turns positive. So we get 2 plus y squared is equal to 9. I subtract 2 from both sides. I get y squared is equal to 7, and we would take the square root of both sides. Now, when we take the square root, we would add a plus or minus to that numeric side, but because we are dealing with a very specific place, we are dealing in the second quadrant where y is positive, we only consider the positive case, so y is the square root of 7. So we know one ordered pair on this theta is the negative square root of 2 and the square root of 7. So we're going to just roughly figure this out. The negative square root of 2 will be in between negative 1 and negative 2. And the square root of 7 will be somewhere in between 2 and 3. So it's going to be, like maybe right here. We'll just do that. And there's our theta. Okay, gorgeous. Okay, that wasn't the straightest line, but that value, this length from here to here is a length of 3 because that's our radius. We have our x, which is the negative square root of 2. And we have our y, which is the square root of 7. Okay, now that we have all this information, we've sketched the graph, so this is done. Now we need to find tangent of theta. And remember what I said, tangent of theta is y over x. Y is the square root of 7. X is the negative square root of 2. This indicates to me that tangent is negative in quadrant 2, which it is. I also want to rationalize the denominator. To rationalize the denominator, I'm going to multiply by the irrational 2. Negative square root of 2 times square root of 2 is equal to 2. And I'm going to put that negative out in front, right? If we have one, either the numerator or the denominator is negative, that makes the whole fraction negative. Here we have the square root of 7 times the square root of 2 is the square root of 14. So we have tangent of theta once and for all is the negative square root of 14 over 2. Last but not least, cosecant. Cosecant of theta is r over y. R is 3, y is square root of 7. I am expecting cosecant to be positive. I hesitated because I was worried that it was positive, but since sine is positive in quadrant 2, so is cosecant. Let's rationalize this denominator by multiplying both the numerator and denominator by the square root of 7. And we have cosecant of theta is equal to 3 times the square root of 7 over 7.